Hello everyone, welcome to my YouTube channel Pole Chemistry. Today we will discuss about chemical calculations with the help of mole concept. We know that every chemical equation must be balanced according to law of conservation of mass. You know from class 9 onwards. So from the balanced equations, we can calculate the amount of products from a particular amount of reactants. That is mass-mass relationship, volume-volume relationship for gases, number of molecules, number of atoms, etc. We can correlate between the number of atoms, number of molecules, masses, volumes in between the reactants and products in a balanced chemical equations. So let us proceed with an example. Magnesium burns in air to produce magnesium oxide. This is a chemical reaction. The reactants are magnesium and oxygen, the products are magnesium oxide. So this is not a correct chemical equations. You know, it is skeleton equation. That is, the number of atoms of reactants, number of atoms are not equal. According to law of conservation of mass, you know that mass neither be created nor be destroyed. So to balance the masses of reactants and products, number of atoms of reactants, number of atoms of product must be equal. That is called balancing. You know that. So first of all, we have to balance the equation. Magnesium 1 atom, oxygen 2 atom forming one molecule, and here oxygen 1 atom. That is why coefficient 2, twice magnesium, that is why twice magnesium atoms, twice oxygen, twice oxygen. This is the balanced equation. This is the correct chemical equations. Okay? So balanced equation reflect 2 mole of magnesium completely reacts with 1 mole of oxygen, coefficient is 1, then 2 mole of magnesium oxide is formed by the reactions. This is the complete requirement. So to consume both the reactants, we have to react 2 mole magnesium with 1 mole of oxygen, then they will be consumed completely. Thereafter, 2 mole of magnesium oxide will be formed by the reactions. Now we can convert mole into mass from mole concept. So 2 more magnesium, that is 2 into 24 gram. Because you know magnesium atomic mass is 24. Oxygen atomic mass is 16. You know that. So 2 more of magnesium twice Mg, that is twice of 24 gram, that is 48 gram magnesium. 2 more magnesium completely reacts with 1 mole oxygen, that is 2 atoms of oxygen, that is 16 into 2. That means 32 gram of oxygen. So balance equation clearly indicate that 48 gram magnesium require 32 gram of oxygen for complete consumption to produce 2 mole of magnesium oxide, that is twice of 24 plus oxygen is 16. That means 2 into 40 gram, that is 80 gram. So you can see it is clearly visible that law of conservation of mass is valid. Mass of reactants is 32 plus 48 is equal to 80, and mass of products 80 gram. 80 gram, 80 gram. So masses neither be created nor be destroyed. So law of conservation of mass is valid. So according to mole concept, applying mole concept, we can convert mole into atoms, mole into molecules, etc. Then mole into gaseous. Is gaseous substance mole into volumes, applying mole concept. You know, 2 mole magnesium, twice magnesium contain twice of Avogadro's number of atoms. 1 mole oxygen, that is Avogadro number of molecules. You know Avogadro's number Na equal to a definite number 6.022 10 to the power 23. That number is Avogadro's number. Symbol is Na, Avogadro's number. 1 mole contains this number of molecules. So 1 mole oxygen means this number of molecules. That number Avogadro's number. So 2 mole magnesium oxide, that is twice of Avogadro number of molecules will be formed. So as per number of molecules and atoms from the balanced equation, we can say that twice of Avogadro atoms of magnesium completely react with Avogadro number of molecules of oxygen. Then they will be consumed completely to form twice of Avogadro number of molecules of magnesium oxide. This is the molecule relationship. This is the mass-mass relationship. This is the mole-mole relationship between reactants and products as per the balanced chemical equations with the use of mole concept. Out of the reactions and products, you know, magnesium is solid state, oxygen is gaseous state, magnesium oxide is solid state. So gases, you know, gases have volume. As per mole concept, we know 1 mole of any gas occupy a definite volume, that is the molar volume, and that volume at STP condition is 22.4 liters at STP condition or NTP condition. So this is the volume relation, mass, volume, atoms, molecules, masses, etc. This entire process is very much important for various numerical calculations. This process is called chemical calculations. So let us proceed with the problem. Everyone write down. So for this problem, magnesium oxygen to produce magnesium oxide. Write the problem. 12 gram of magnesium burns in air. Calculate the amount of magnesium oxide formed. In this reaction. So, look at this. This is the magnesium, 12 gram magnesium. Mass of magnesium is given. Burns in the air. Okay, air means oxygen. The amount of magnesium oxide formed in the reaction to be calculated. So, amount of magnesium oxide, that is mass of magnesium oxide. So, this is called mass-mass relationship. This is called what? Mass relationship to solve the problem. Apply more concept. So to do the problem, to solve the problem, first you write the balanced equation. Magnesium reacts with air, so magnesium reacts with air. To form magnesium oxide. First you balance the equation. You have to write again magnesium plus oxygen to give magnesium oxide. Balance the equation first because calculation to be done from the balanced equation. From balanced equation, 2 mole magnesium, 1 mole oxygen, 2 mole magnesium oxide. Thereafter, you need mass-mass relation. Magnesium. 2 mole magnesium, that is twice of 24 gram, that is 48 gram. As per balanced equation. In air is available, so oxygen is excess amount. So, amount of oxygen actually not necessary for this problem. I will discuss later on. Amount of magnesium oxide formed, that is amount of magnesium oxide, that is mass of magnesium oxide. So, in this problem, molecule is not necessary. Molecule, atoms are not necessary, volume is not necessary. Because everyone, this is very important. Mass-mass relation, that is why mass-mass relation. No need to write molecules, no need to write volumes for this problem. Okay? So, balanced equation reflect that 48 gram magnesium produces 80 gram magnesium oxide. But in this problem, 12 gram magnesium in air is excess air. Air is excess. Okay? Air is excess. As per balanced equation, 48 gram magnesium reacts with 32 gram air to produce 80 gram magnesium oxide as per balanced equation. In this problem, 12 gram magnesium reacts with air. Air is excess air. Then how much magnesium oxide formed? So this to be calculated. This mass-mass relation, mass of magnesium is given 12 gram in the problem and amount of magnesium oxide formed to be calculated. This to be calculated. This mass-mass relationship. Note down carefully. So how to do? What to do? As per balanced equation, you write 48 gram magnesium. I am writing here. I am writing this thing. So as per balanced equation, look at this. 48 gram magnesium produces 80 gram of magnesium oxide as per balanced equation. Therefore, 1 gram of magnesium produces 80 by 48 gram of magnesium oxide. Unitary method. Simple mathematics. Therefore, how much? 12 gram of magnesium produces 80 by 48 into 12 gram of magnesium oxide. So 12, 4 times 4, 20. 20 gram of magnesium oxide. So calculation is done. So as per balanced equation and with the help of mole concept, easily we have calculated 12 gram magnesium when bonds in air, excess air, then 20 gram of magnesium oxide is formed in the reaction. So after calculation, this is 20 gram. So this type of calculation is called chemical calculations. Okay, again we can convert this mole into volume as per the molar volume. 1 mole occupied 20.4 liters. Then volume mass relation, mass relations, mass number of atoms, number of molecules relationship, etc. can be done as per the requirements. So this is called chemical calculations. So I hope you all understand about the chemical calculations, stoichiometry based calculations. So first of all, again I am repeating one thing. To do the chemical calculations, you have to balance the chemical equation first. Then as per the balanced equations, you write the required amount of moles of the reactants and the amount of moles of the products so formed in the reactions. As per the balanced equation, you have to do the problem. Then look at the problem, what is given and what to calculate. In our problem, whatever we have done, masses of magnesium is given, masses of product to be calculated. So mass relationship, that is why mole is converted to mass, mole is converted to mass relations. Then 12 gram magnesium, as per balanced equation, 48 gram magnesium produces 80 gram. Then 12 gram magnesium reacts with excess air. How much magnesium oxide is formed? This is called mass relationship, already done. And one important thing I have to explain here. Then when more than one reactants are there in a chemical reactions, first of all, you have to analyze the question that out of the two reactants, which reactant is consumed first? Out of the two reactants, when any different amount of reactants are used for the reactions, then out of the two or more reactants, one of the reactant will be consumed first. That amount will be consumed by the reactions, automatically reaction will be stopped. Whatever be the excess amount of other reactant may be, but the reaction will not occur. Because one of the reactant is consumed first, so reaction will be stopped. That is, production of the reaction will be stopped. So to do the calculation, to calculate the amount of product formed in that reactions, you have to understand which reagent is the consuming first. That reagent is called limiting reagent. Note down very carefully. So in this reaction, look at this. Magnesium burns in the excess air. So air means oxygen is available. So amount of oxygen is available in the reactions. But the amount of magnesium is limited. Only 12 gram magnesium is used for the burning process. That is, 12 gram magnesium will be consumed first. Oxygen is available, excess air is there. So magnesium is the limiting reagent in this problem. It's called limiting reagent. That is consumed first. So calculation to be done from the limiting reagent always must. You have to remember this particular point. To calculate the amount of product, you have to analyze the problem and which reagent is the limiting reagent. And calculation should be done from the limiting reagents. That is why magnesium, in this problem, magnesium is the limiting reagent and calculation is done from the limiting reagent because another reactant oxygen is available excess. So whatever be the excess amount of oxygen, further production will not be happened. So whatever be the excess air, magnesium oxide will be 20 gram only because 12 gram carbon is the limiting reagent, limiting amount. That amount will produce 20 gram of magnesium oxide. Whatever be the excess amount of air may be, no more magnesium oxide will be formed. 20 gram of product will be formed from 12 gram of magnesium, that is the limiting reagent. Whatever be the excess quantity of the air may be, production will not be happened. Again, this is the very important point for chemical calculations. So students, I hope you understand about the chemical calculations, about the limiting reagent. So today I discussed about chemical calculations. I hope it is important class to you and you have benefited by this class. So if you think that this is beneficial to you, So please